In this video, we are going to look at the derivative of other trig functions. So we already know that the derivative of sine is cosine, and that the derivative of cosine is negative sine. So we're going to look at the other reciprocal functions of those as well as tangent. So first, a couple identities. Remember that the other trig functions that we typically consider are kind of just combinations or rearrangements of sine and cosine. So tangent of x we can rewrite as sine of x over cosine of x. Cosecant x is 1 over sine of x. Secant of x is 1 over cosine x. The way I remember these pairs is each pair has a co. So cosecant goes with sine. Cosine goes with just secant. If we have two cos together, then they're not right. And then cotangent is 1 over tangent of x, which is also the same as the cosine of x over the sine of x. So here we'll just look at a table of all the derivatives. So we already know sine, derivative of sine is cosine, and the derivative of cosine is negative sine. Now the other ones are not as simple to just look at and memorize. For example, the derivative of the cosecant of x is a negative cosecant x cotangent x. The derivative of secant x is a secant x tangent x. Tangent x is a secant squared. Derivative of cotangent is a negative cosecant squared. And if you just try to memorize all of those, it could be pretty easy to mess up which one needs the positive, which one needs the negative, which one is has the cos. I guess it's kind of convenient that like cosecant has cosecant and cotangent. Secant just has secant and tangent. Same with tangent goes to secant squared. Cotangent goes with cosecant squared. So if you want, you can memorize this table, but sometimes our memory fails us, and so it would be useful to be able to figure these things out. So we'll do one example where we will use the quotient rule to figure out what the derivatives are. Because if we know sine and cosine, since all of these are just a fraction that involves sine and cosine, we can use the quotient rule to find the derivative of any of these if we happen to not remember exactly what it is off the top of our heads. So to find the derivative of cosecant of x, we would rewrite that as 1 over sine of x, and we will apply the quotient rule. So in our quotient rule, remember we take low d high, so we have sine of x times the derivative of the top, derivative of 1 is 0. Take high, so that's 1. D low times the derivative of the bottom, so derivative of sine of x is cosine of x, and that's all over the bottom squared. So sine squared of x, which is equivalent to sine of x squared, but it's easier to write sine squared of x. So on the top, sine of x times 0 is 0, so we have a negative cosine of x on top, sine squared of x on bottom. Now that looks different than what we had. Remember we had, which one are we doing? Cosecant here. Negative cosecant x cotangent x. So let's see if we can get into that form. I'm going to split this up into two separate fractions. So we have a negative 1 over sine x times a cosine over sine. Do we see how that's the same? We have a negative 1 on top and a cosine, so those are multiplied. And then on the bottom, I just split up the two different signs that we have. Negative 1 over sine x is a negative cosecant x. And then cosine over sine is a cotangent of x. So there we get the derivative. And we could do that with any of those in the table. We could do that with tangent, cosecant, secant, or cotangent. As long as we know sine and cosine, we can figure these out when we need to.